All right, it's 2025. It's actually early 2025, and I thought I'd take some time to sort of explain a little bit about what I'm seeing in the AI space specifically. And I want to take this time to project out some of my predictions for 2025, especially when we're seeing so many things happening in the AI space. And 2024 was really exciting. We saw a lot of milestones, but I think 2025 is going to be interesting. It's going to be unique. And I want to spend some time today speculating about some of the 8 biggest trends I see taking shape in AI right now, and why I really think that this year is going to really set the path forward and the foundation for the next frontier of AI. But before we jump in, if you like this channel, if you like the content, I've noticed that 98% of viewers who attend this channel are not subscribed. So if you are one of those, thank you for stopping by. And if you do like the content, give it a subscribe. You'll get notified next time a new video and content like this comes up. So without further ado, let's dive in. So I want to talk about Agentic AI. I think this has been probably the hardest topic of 2024 and going into 2025 as well. And there's a lot of talk about what Agentic AI is actually going to look like. People are really excited about this space because it means that a lot of the tasks we've done in the past that are menial, that are boring, can now be properly automated. And this is where I think 2025 is going to be the big shift in Agentic AI. So things like booking travel, accommodation, buying gifts, going shopping, and ordering takeout. These are simple things that we all take for granted and we do frequently. But it's so nice to hear that this could potentially be taken over by AI to help, free our time to do other things, to do more important things as well. And I think there are 3 major components to having a properly functioning Agentic AI. One of them is reasoning. Now, we've already seen this with OpenAI's O1 model and O3 model that was recently released in late last year in December. And we're starting to see trickles of things around thinking models. And what this means is that now we're starting to see this sort of transition point where these AI LLM models are starting to reason for themselves. And this is extremely important because now you're starting to see models start to question its answers. It's starting to figure out, am I sort of on this right path of thinking? Am I following this right path? Should I deviate and should I go somewhere else? That's really unique for an AI. And we're starting to see those in Anthropic's model, in OpenAI's model as well. So reasoning is a really crucial part of that. And you can see in OpenAI's diagram here is that as it starts to iterate and starts to think for itself, it's using the output tokens and the input tokens for the next iteration and the next line of questioning as well, eventually coming to some sort of threshold conclusion where it's going to spit out the answer. This is really unique, and this is going to pave the way for Agentic AI and even more bigger things than that. The second part of it is intelligent tools. We've seen recently how Anthropic's Claude Sonnet 3.5 has successfully been able to access certain things on your computer, like your keyboard and your mouse and your API. So this is going to be incredibly important for Agentic AI to take hold. And the last thing is memory access. And once the AI model is able to understand who you are, understand context, this is where it becomes super powerful because it knows who you are as a person. It's also kind of scary as well. It knows who you are. It knows what your likes and your dislikes are. It's then going to be able to use a combination of reasoning, intelligent models, memory access, conduct web search on your behalf to access certain connectors, whether it be connecting to Airbnb, connecting to Google Flights, connecting to your favorite services. And it's also going to be able to access your mouse, your keyboard, and your screen, being able to take screenshots as well. So this is really crucial in the way the Agentic AI paradigm is going to be created. And again, Claude Sonnet 3.5 was sort of the flagship model of that. And we've seen really, really powerful demos of that taking shape.
What we're going to do is ask Claude to look at the spreadsheet, check if AMP equipment is in there, and if not, move over to the CRM and try and find some more information there. Once it has this data, Claude's going to then fill out the form for us and hopefully transfer the information across to the vendor form. The first thing that's going to happen is Claude's going to start taking screenshots of my screen and quickly realizes that the Ant equipment company isn't actually in the spreadsheet. So the first thing it does is it swaps over to a CRM and searches for the company we're interested in. Luckily, we get a search match, and Claude then starts scrolling through the page, looking for all the information it needs to fill out this form. Claude then autonomously starts transferring the information across without me having to do anything, and goes through the steps and fills out all the information needed. And then submits the form. This example is representative of a lot of drudge work that people have to do. This is available in the API. We're excited for people to try it, and we should expect things to get a lot better over the coming months.
So I think the one takeaway here is that Agentic AI isn't for every question. So you've probably asked ChatGPT questions like, write me a letter to an investor, or tell me how to write a Christmas card for my family and friends. That's not what it's used for. Agentic AI is used for very complex and broad problems with multiple decision steps. Just the way that you're deciding to invest in a stock, you're trying to book accommodation or book travel. This is where Agentic AI becomes really, really powerful. It's not for the simple stuff. It's much more for the complicated decisions you have to make in your day-to-day life. So the next thing I want to talk about is how AI is being introduced into more and more industries with hyper-specialized AI models. We're starting to see a transition from the generic ChatGPT style AI models to much more niche style models, as you can see. And this is now being applied in a lot of other industries like healthcare, finance, energy, manufacturing. These are the industries that move the needle for a country, if you think about it. And there's a lot more industries like mining, natural gas, industries where you wouldn't otherwise think about AI being useful can now be useful. And I think with Agentic AI, with smaller, specific, specialized AI models, you're now starting to train these models to become hyper specific on specific data points and specific industry needs that could be very, very useful. So the biggest takeaway here is that we're now starting to see a proliferation of devices. Could be, devices at the edge. It could be your TV. It could be devices in the field. It could be your mobile device. The models are getting specialized, means that they can now get pushed to the edge, which means that there's less processing, it's less expensive, it's more convenient and cheaper. This is going to be the next paradigm of what AI models for specific use cases, which is really exciting. So the general takeaway here is that AI is going to be much more used. It's going to be much more available and ubiquitous in more industries, and that's exciting to see. The next thing I want to talk about is how a lot of these industries are now going to be in the physical world. We've seen already how AI has already tackled marketing, B2B SaaS, a lot of these online industries, but we're now starting to see with the likes of robotics, the likes of manufacturing, how AI is taking a stronghold in some of these industries. And, starting to see this with logistics, with personal use like Tesla and Figure, the humanoids that are now being developed so that they can help you or loved ones at home. This is where AI will also be used significantly. We've also started to see stuff happening with self-driving cars. Personally, I've taken Waymo in San Francisco, and it's incredible. And it's funny to see how over the past couple of years where you've seen Tesla and Uber and other competitors compete against the self-driving market, you're now starting to see Google's Waymo take shape and now blow everyone out of the water. And I think with all the developments in generative AI and AI in general, self-driving cars is going to be the next big thing. And slowly but surely, Waymo is expanding into other cities around the country and hopefully around the world as well. And then the last thing to note here is how companies like NVIDIA, who have been specifically focused on building semiconductor AI chips and GPUs, they're starting to now understand the power of AI across industries. So recently, they've developed something called the Omniverse. Take a look at how NVIDIA is actually going to use Omniverse to apply AI to the physical world.
For 60 years, Software 1.0, code written by programmers, ran on general-purpose CPUs. Then, Software 2.0 arrived, machine learning neural networks running on GPUs. This led to the big bang of generative AI, models that learn and generate anything. Industrial enterprises use physical AI to automate physical work. Physical AI embodies robots like self-driving cars that safely navigate the real world, manipulators that perform complex industrial tasks, builds 3 computers to enable developers to create physical AI. The models are first trained on DGX. Then, the AI is fine-tuned and tested using reinforcement learning physics feedback in Omniverse. And the trained AI runs on NVIDIA Jetson AGX robotics computers. NVIDIA Omniverse is a physics-based operating system for physical AI simulation. Robots learn and fine-tune their skills in Isaac Lab, a robot gym built on Omniverse. This is just one robot. Future factories will orchestrate teams of robots and monitor entire operations through thousands of sensors. The era of physical AI is here, transforming the world's heavy industries and robotics.
So with all the talk around hyper-specialized AI models being used at the edge and in the real world, I think it makes sense to understand where AI is heading. And I think the LLM models we have today are significantly large. They're really, really big, right? These models are huge, they're expensive, they're costly to run. But the problem is that we now need to figure out what is the thresholds that these large language models are going to reach. So I want you to take a look at this graph that shows how back in the 1950s and 60s, the parameters used in AI models, very, very basic AI models for that matter, were around the 40 to 50 mark. Now, if you fast forward to 2000 and sort of 2000 to 2025, there's been an absolute explosion in the number of parameters being used in these AI models. Now, it's great to see. It's great to see that there's so much hype and there's so much compute power being dedicated towards building these large language models. We've seen this in ChatGPT and other models alike that are getting smarter. But what we've seen is that there's thresholds to be reached now. It doesn't mean that a larger model means a smarter model. Eventually, you'll get problems around overfitting and things where models are not being innovative enough and they're just relying entirely on memory, and that's a bad thing. So you want the flexibility of these AI models to create innovation for you in the way that they think. And so now there's been a push towards focusing on building reasonably sized models, I would say. They're not super big, but they're enough to generate the innovative outcomes that you want for a model. So I think the biggest takeaway here is that there's going to be going back off the physical world, off the specialized domains. AI is going to be used in very specific use cases, but I think that there's also a focus on something very interesting here called inference time thinking. And that's the next area of development I want to talk about. We can call it inference time or test time compute. This is all the rage right now because we're now starting to see how companies like OpenAI and Google are developing models that are focusing their efforts on the inference part of AI models versus the train time. So just to be clear here, there's two parts to this. So the old world was where we saw that exponential jump in parameters being used, right? The data being used in these models are being pre-trained. That means that there's a lot of effort, a lot of energy and resources being put into the training of these data points to produce these models. This is obviously more power hungry. We've seen this be more expensive. NVIDIA, a lot of other companies out there are riding this wave where there's a lot of focus and resources going into this. But now there's a new world and it's called test time compute. This is where all the decision making, this is where all the outcomes are being derived from test time, from inference time, so to speak, where all the training has been done, but now it's really up to the model to figure out, am I coming up with the right answer at the inference level? So this is where it becomes cheaper. It also means that the model takes a longer time to think, which is actually a good thing. And as I mentioned before, going back to the agentic AI paradigm, we're starting to see AI think for itself. It's starting to realize its capabilities, but then also think like a human, because humans don't make decisions quickly. They take time, they do the research, they question their answers, and they feed back into the next iteration of answering as well. And this is exactly what test time compute is all about. It's creating outcomes at the inference level. It also means that test time compute models can take longer time to solve harder problems and more complex problems. So I want you to take a closer look at this graph from Hugging Face. And there is two models here. There's the Llama model, 8 billion parameter model, and there's the Llama 3.1, 70 billion. These are the huge large language models that we've spoken about. But take a look at the orange lines and the blue lines. And specifically in the circled areas, these two lines represent a smaller representation of the models, one at 1 billion and 3 billion parameters respectively. And then you can see that over time, as the number of generations per problem increase, as the number of iterations increase basically, the performance of these lower parameter models are beating the 70 billion and 8 billion models. So that's actually really interesting to see. And I think that paves the way and gives you confidence for the way that these types of specialized models, but also on how these smaller language models can actually play a big role here. The one thing that I haven't really touched on yet, and no one has really spoken about actually, is infinite memory. So if you've used ChatGPT in the past, you've probably had to give it some context. You've had to give it some idea about who you are, what are your likes, what are you looking for, and over time you start to give it more information. And over time it starts to get better and better and better. Now the problem with these types of context windows is that they're only finite. At some point, ChatGPT is not going to absorb more information about what you want. And this is where the finite context window problem occurs. Now, what we're starting to see now is that the experience has been a bit lackluster. People are not using ChatGPT to its fullest extent because it knows that the context window is finite. So this is where it would be so cool if we could find a way to create infinite context memory. So this is where the AI model will know everything about you in hopefully a good way. It will know exactly your profile. It will know the things you like and the things you don't like. It will know your preferences, and it will just keep that forever. And then over time, as you start to provide more information, it gets better and better in learning more about you. There's been a lot of talk about why this is so important. And one of the things it does is that it provides a much more richer and deeper experience. But it also means that it becomes a competitive advantage for a lot of these companies. And Google specifically have started to do exactly this. They've started to research, develop models and solutions around creating these efficient infinite context transformer windows. So that's just to give you a sense of where this is going. And again, this ties back to agentic AI. It's going to need context about you in order to execute the tasks that you want. So this is really exciting, this new one called Large Concept Models, LCMs. This was recently announced by Meta, Facebook Research, and they basically created a new type of way of creating models. So let me just give you a sense of what this looks like. Right now, these large language models process input and generate output using tokens. So the words that you and I speak, the words that we type, all of them have been somewhat tokenized. Now, the problem is that humans don't make decisions in tokens. They don't make decisions based on certain words. They make decisions on concepts. So this is where high-level abstraction comes in, right? The way that we start to formulate ideas, the way that I'm giving this talk to you right now, I'm not making this talk based on every single word. It's not fully scripted. I have a concept, I have an idea of what I want to talk about, and then the actions follow after that. This is exactly what Facebook is trying to do as well at the algorithmic level. They're trying to create a model not based on tokens, but actually based on sentences. So just the way that I would describe something, these LCMs are doing exactly that. They're taking sentences as high-level concepts, high-level abstractions, and then decoding that into something a bit more contextual for the model. So I think the biggest potential here is that it can lead to better performance, it can lead to better efficiency as well, and it's also agnostic when it comes to language and modalities. You can feed it pictures, you can feed it video, audio, text, it doesn't matter. And this is one way to view the way that LCMs work, and this was provided by Facebook. As you can see how on the left-hand side, you've got these sentences that have then been converged into two very simple concepts. And then from that, you can see the input coming in that are being encoded into concepts, and then the LCM spitting them out, right? So that's sort of the new way that potentially AI could look like. We haven't yet fully proven the performance levels of what this looks like, but it's super exciting to see. And then finally, I want to touch on something very, very interesting, more of an observation than anything. And I think one thing that I'm starting to see slowly but surely is that inference is taking over training. What do I mean by that? Well, I think it's safe to say that pre-training is getting more expensive and resource intensive. We've spoken about that already. We know that hundreds and billions of dollars are being used to funnel into building data centers, are being funneled into research and development of better ways to create GPUs and AI processing chips. But now, with everything that's been happening, there's only so much data that can be trained upon. At some point, we're going to reach a peak. And we call this the sort of the peak data of everything. And Ilya Sutskever, one of the co-founders of OpenAI, said to the effect that we are reaching a point of training stagnation. Basically, we just don't have enough data. We have all the data in the world, but there's going to be a point where every piece of data is going to be trained upon. And then what happens next? Here's a quick video of Ilya giving a presentation explaining this very fact.
But pre-training as we know it will unquestionably end. Pre-training will end. Why will it end? Because while compute is growing through better hardware, better algorithms, and larger clusters, right? All those things keep increasing your compute. All these things keep increasing your compute. The data is not growing because we have but one internet. We have but one internet. You could even go as far as to say that data is the fossil fuel of AI. It was like created somehow, and now we use it, and we've achieved peak data, and there'll be no more. We have to deal with the data that we have. Now, it's still let us go quite far, but there's only one internet.
So what does this mean? I think as a summary to everything that we've seen so far and everything that I potentially see coming in 2025, I think there's going to be a few focuses. One of these focuses is going to be on reasoning, as we mentioned about. And then the next thing will be on inference level thinking, which is going to be super critical to feeding that into reasoning, feeding that into agentic AI. And the last one is more efficient models. I think it's going to be exciting to see where this goes. I'm really excited to see where this takes off. I'm really excited to see how companies like Google, OpenAI, Amazon, Microsoft are building these models. And then from there, figure out, are we reaching a threshold? Are we reaching a limit? Or are we just getting started? If you like this content, I really hope you enjoy it, and give it a subscribe, give it a like, share it with friends, and I hope to see you in the next video. All right, take care. Bye-bye.